Hello, ladies and gentlemen, and welcome to our fascinating journey into the world of sound waves. Whether it's the rustling leaves, the chirping of birds, or your favorite song playing, sound waves are all around us, shaping our daily experiences. So, what exactly are sound waves, and how do they work? Let's dive in and find out. Sound waves are created by vibrations. Imagine plucking a guitar string. As the string vibrates, it moves the air particles around it, creating waves of pressure that travel through the air. These waves are what we hear as sound. Sound waves are mechanical waves, meaning they need a medium like air, water, or solids to travel through. They cannot travel through vacuum like space because there are no particles to carry the vibrations. Sound waves are also longitudinal waves. In a longitudinal wave, particles of the medium move parallel to the direction of the wave. This can be easily visualized with a slinky. When you push and pull one end of the slinky, you create compressions and refractions to travel along its length. The two key characteristics of sound waves are frequency and amplitude. Frequency is the number of waves that pass a point in 1 second, measured in hertz. High frequency means a higher pitch. Amplitude is the height of the wave and determines the loudness. The greater the amplitude, the louder the sound. Now, let's see how we hear these sounds. Sound waves enter our ear canal and make the eardrum vibrate. These vibrations are transferred to three tiny bones in the middle ear, which amplify the sound. Finally, the vibration reaches the cochlea, the inner ear, where they are converted into the electrical signals and sent to the brain, and voila, we hear sound. Different objects create sound waves in unique ways. Drums produce sound through the vibrations of their skins, tuning forks through their metal prongs, and speakers through their diaphragms. All these vibrations set air particles in motion, creating sound waves. And now, some fun facts about sound waves. Did you know the sound travels faster in water than in air? In fact, it's about 4 times faster. The loudest sound ever recorded was the eruption of Krakatoa volcano in 1883. It was so loud that it ruptured the eardrums of people 40 miles away. Some animals, like dogs and bats, can hear ultrasonic sounds, which are frequency higher than the human hearing range. Now let's delve a bit deeper. Sound waves can reflect, refract, and absorb when they encounter different materials. Reflection of sound waves causes echoes. Refraction happens when sound waves changes direction due to change in speed, like when moving from air to water. Absorption, on the other hand, occurs when the energy of sound waves is taken in by the material, converting it to heat. Another fascinating phenomenon is the Doppler effect. Have you noticed how an ambulance siren sounds different as it approaches you compared to when it moves away? This change in pitch is due to the Doppler effect, which occurs because the sound waves are compressed as the source moves towards you and is stretched as it moves away. Sound waves can also be classified based on their frequency. Infrasound refers to sound waves with frequencies below 20 Hz, which humans cannot hear, but elephants can. Ultrasound, on the other hand, refers to frequencies above 20,000 Hz, which are used in medical imaging and by bats for echolocation. To recap, sound waves are mechanical and longitudinal waves, requiring a medium to travel through. Their key characteristics include frequency and amplitude, determining pitch and loudness. Sound waves can reflect, refract, and absorb, and phenomena like the Doppler effect showcase their dynamic nature. Understanding sound waves gives us insight into everything, from musical acoustics to advanced technologies like ultrasound imaging. And now, a few more fun facts. Human speech is typically between 85 to 255 Hz. That's why we cannot hear our dog's high-pitched whistle. Whales can communicate over hundreds of miles underwater using infrasound. The speed of sound is about 343 meters per second in air, but it's much faster in solids like steel, traveling at around 5,960 meters per second. Sound waves are truly amazing, and they play a crucial role in our lives, from communication to enjoying music and understanding the world around us. We hope you enjoyed this introductory video into the world of sound waves. Stay tuned for more exciting explorations into the wonders of science. Thanks for watching.